Ladies and gentlemen, I'm Codex, and welcome to the laboratory. This is an LED. This is how you power an LED. Unfortunately, if you want to do this little blinky thing, you might not have time to press a button all day. Well, you can say hello to my little friend. It's a 555 timer chip. And it's one of the coolest circuits that I know of that I don't completely understand. And there you go. Behold, ladies and gentlemen, we have a blinking, albeit a very weak blinking LED light. But how does it work? What is going on inside this little black chip that's making our LED blink? I don't know. Look it up. Now here's the diagram for that circuit we just built. We have resistor A, resistor B, our capacitor, our LED, and obviously the timer chip itself. The values of resistor A and B are written over here, as well as the value for C1. Now this UF thing means 10 to the minus 6, or 1 millionth. So if you multiply that by 10, you get this. And this is called picofarad. So yeah, resistor A is 1 kilo ohm, resistor B is 100 kilo ohms. Although technically, if you look at the diagram, since resistor A and B are in series, technically the resistance of B is 100k plus 1k, which is 101k. Now, if you want to calculate the frequency at which, your LED will blink on and off, you got to use this formula. Now, if we plug in the values from earlier, although we have to use this value for resistor B, and you follow the math, you get 0.7 hertz, which is roughly equal to 1 hertz, or 1 blink per second. And if we look at our circuit, that's what we see. It turns on, it blinks at around 1 hertz, or around 1 time per second. Now, what if we want to change the frequency for this circuit? Well, and if you look here, like so, if I swap this capacitor out, you can see that this one blinks a little bit faster. Well, blinks quite a bit faster. And the value of this one is, there you go. I'm not sure if you can see it. Camera will focus. But it says 7 picofarads, which obviously if you plug that into the formula at home, it increases this frequency. Now you might be thinking, yeah, this is cool and all, but what's the actual purpose of a circuit like this? Like, what's the purpose of a chip that just makes LEDs do that? What's the point? You think you're smart, huh? Well, answer me this, and I don't know, I'll send you $10. What is a system clock, and what does it look like? You're wrong. The answer is perhaps. You see, in a computer, signals are sent all over the place. And to make sure these signals are in sync, you use something called a system clock. Okay? And a system clock, granted the ones in real computers, pulse billions of times per second. They use a circuit like this that generates pulses every now and then. And if your name is Ben Eater, you can use one of these little chips to make a clock for a computer on breadboards, or if you're just trying to demonstrate a design. You can also use this thing for generating single pulses of a fixed length, which is pretty good for debouncing crappy little buttons like this. If you noticed in some of the clips, even though I press it down, the output flickers a little bit. That just about sums it up. If you enjoyed this video, be sure to leave a like, subscribe if you want to see more videos like this, leave a comment down below and give me some ideas for what I can do with this thing. And I'll leave some good links for some more information about the 555 timer if you're too lazy to look it up yourselves. But again, hope you enjoyed, and I'll see you next time. Farewell.